We're going to take a look at the pulley systems problems, which are numbers 14, 15, 16, and 17 on activity 112 Simple Machines Practice. So here we're going to take a look at, we have our first setup is we've got a construction crew that lifts 560 pounds of material several times during the day from a flatbed truck to a 32 foot rooftop. A block and tackle system with 50 pounds of effort force is designed to lift the materials. And what they first off want to know, so they're not having us draw a sketch or anything, but they want us to go through and find out what's the actual mechanical advantage. So actual mechanical advantage for all simple machines is the same formula, same way that we're able to go through and calculate for this. So AMA, resistance force, 560 pounds, that's how much we're lifting. And they say that we are providing 50 pounds of effort force, and we're able to go through and find out what our actual mechanical advantage is. So here we get 11.2 as far as what we have going on there. And again, when we're looking at number of significant figures, lowest amount is 3 significant figures. We're going to match that level of precision. So our AMA is we're going to keep that at 11.2 to 1 on our ratio. Then they ask for number 15. Well, how many supporting strands is needed in order to go through and support that? Now, in this scenario, I'm going to show you on the front page of this activity, this is where this is going to come into play. This little line right here, all problem calculations are assuming ideal conditions and no friction loss. So what this means is that when you're going through and doing that, you're not factoring in any friction loss within this particular, within these problems. Now the only difference between IMA and AMA is the factor of friction. So kind of keeping that in mind, as we go back to number 15 here, is off to the side, I'm going to kind of go through and say that. So if there's no friction loss being considered, then we can safely say AMA and IMA are the exact same thing in these scenarios. So with that being said, we're going to go through and we're going to look at one, if we have AMA is equal to the IMA, and if the IMA is calculated by the number of strands, then we can go through and take a look at that with utilizing the AMA we just calculated. So I had 11.2 for my mechanical advantage, and it's equal to the number of strands. But here's the thing: I can't have 0.2 of a strand in my pulley system. So I actually have to round up for the real world scenario here. We're going to need 12 strands. So rounding rules would say we would round down to 11, but since we have more than 11 to be involved, then we go through and we'll go to 12. Okay. All right, so here's how we go through and we take a look at this now. Got a block and tackle system with 9 supporting strands. So this one here, you got to watch, they've spelled out the word 9. Supporting strands is used to lift the metal lathe in a manufacturing facility. The motor used to wind the cable in the pulley system can provide 100 pounds of force. So they say, what is the mechanical advantage of the system? Well, as you go through and you take a look, they already kind of tell us that they don't specify whether it's AMA or IMA, but again, remember, in these problems, we're not assuming any friction loss. So IMA and AMA are the same thing. So I can say this is equal to the number of strands. Number of strands equals 9. That means our IMA is a 9 to 1. Number 17, they want to know what's the maximum weight of the lathe. So again, kind of the same scenario. IMA is equal to AMA. So when we plug this in, we've got the AMA is equal to the resistance force over the effort force. And as I go through and look at that, so I'm going to plug in, since IMA and AMA are the same thing, I'm going to plug 9 in for the AMA. Resistance force is what we're looking for because they want to know what's the weight of the lathe, and they say that we are providing 100 pounds. The motor is providing 100 pounds of force. And in order to go through and solve this, we are going to multiply by 100 pounds on each side to get FR by itself, which means we've got a 900-pound lathe that is being lifted in this manufacturing facility. This finishes up numbers 14 through 17, and be sure if you got questions or anything, let me know, but this gives you a little bit of a walkthrough of those problems and to have you ready for any assessments later on.